Okay, so we just figured out that our energy was, oops, let's hang on a second. Our energy was 4.77 times 10 to the negative 19th joules per photon. So we know our energy equals 4.77 times 10 to the negative 19th joules per photon. And they're asking us for wavelength. Okay, there's a couple ways of doing that. Oh, I give up. I'm going to have to rub that away. There we go. And before we also had a negative. The negative just meant that it was dropping from n equals 6 to n equals 2 and letting off light. If it had been going from 2 to 6, it would have been absorbing that, and it'd be positive. But after that, we just take the absolute value. So they ask us for wavelength, and so if you look at the list of equations, there's two ways of doing that. You can do, we'll go with the easiest way first. So E equals H times C divided by wavelength. Okay, and so that you have everything you need because H is a constant, which is 6.626 times 10 to the negative 34th, and C is a constant, which is 2.998 times 10 to the 8th, and we have energy already. So we'll solve this for wavelength, which I'll go ahead and do real quick here before I even plug anything in. I'm going to multiply both sides by the wavelength, which cancels the wavelength out, and then to solve for wavelength, I would then divide by energy. So divide by energy on both sides. So my wavelength is going to equal H times C divided by energy. And so I'll go ahead and plug those in. That's going to be 6.626 times 10 to the negative 34th. And we have to like cram this one in. 2.998 times 10 to the 8th divided by 4.77 times 10 to the negative 19th. And we'll see what we get. So 6.626 second function exponent negative 34 times 2.998 second function exponent 8 divided by, not times, divided by 4.77 second function exponent negative 19. So I'm getting a 4.12 times, 4.16 times 10 to the negative 7th. And that's in meters, because the speed of light was in meters, okay? So if I wanted to convert that to nanometers, you could look up and say for every 1 nanometer, there's 1 times 10 to the negative 9th meters. When you divide that out, that means you will have 416 nanometers. So you're very close. You're like in the purple ultraviolet range. This is almost, it might be visible as purple, but it's very, very close, like purple ultraviolet range on your light spectrum. So that's how you could get from energy to wavelengths, and just knowing what levels you dropped from in the hydrogen atom.
Oh, yeah.